Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue analyzing the different components that the LAN data system consists of. So fasten your belt and let's get started. The aim of this tutorial is to learn about the other components that the LAN network consists of, like the patch panel, the patch cord, the cable organizer, and the power distribution unit. So we need to learn about all of those components to be able to select the suitable ones of them according to our designing case. So let's go ahead. First of all, we find that the third component we have in the LAN system after the data cable is the patch panel. And this patch panel is the component that is used as an intermediate between the data switch and the data cable. And the main usage of this patch panel is to isolate the data switch from the connected cables, as the patch panel is connected to the data switch with a small copper cable that is used the patch cord, and this connection becomes fixed or it's a non-changed one, and this is to keep the data switch safe with no shocks or no problems that the switch may be exposed to during the working operation of the system. And what will be variable in the connections and that is able to be changed or to be connected or disconnected is the main cable connection between the patch cord and the devices themselves, and what will be variable in the connections and is able to be changed, connected or disconnected is the main cable connection between the patch cord and the devices themselves through the main data cable that is extended to the connected devices. So if this is the data switch, this will be a small copper cable connected for each port of the switch ports. Suppose we are having 24 ports switch, so those will be 24 small copper cables as a connection between the switch and the patch panel, which are called the patch cords, as we will learn later. Then we will have a patch panel connected to the patch cords from its second terminal. Then the patch panel will be connected to the data cable from its face with 24 cables, as the patch panel will have the same number of ports of its corresponding data switch. Then the cables are connected to the required devices in the LAN network. So the main cables can be varying or connected or disconnected, but from the patch panel, not from the switch, and this is to isolate the switch or to keep it safe as much as possible. And this is because the switch is the most sensitive part and expensive part in the system. And here we find the shape of the patch panel to look like this one. You can see it consists of a number of ports that are numbered to organize the connections of the cables to the different devices, as each device on the network is taking a number that is corresponding to a number on the patch panel. So the patch panel helps us also to organize the data system by giving each cable and each device a certain number. And for the capacity of those patch panels, the most popular capacities are 12 ports, 24 ports, and 48 ports. So it can be connected to 12 cables, 24 cables, or 48 cables. Also, we find that this is the actual shape of the patch panels inside the rack after the installation process, as each switch is having a corresponding patch panel. So this is a patch panel, and this is its corresponding switch connected to it through the patch cords. Also, this is another patch panel, and this is its corresponding switch, and they are connected through the patch cords as we said. But this patch panel is not having just one type, as there are two types of the patch panels according to the type of the cable connected to it. And for the first type of the patch panels, we have the copper patch panel, which we have just illustrated, which is used for the CAT cables or the copper cables as a link between the data switch and the different devices on the network. Also, the second type of the patch panels we have is the fiber optic patch panel, and it's used as an intermediate between the fiber optic main cable that is coming from the internet service provider and the outgoing fiber optic cable that is connected to the main switch or the core switch in the network. So what happens here is that the main fiber optic cable is not connected directly from the internet service provider to the core switch, but it passes on the fiber optic patch panel as an input. Then there is an output fiber cable that is connected from the fiber optic patch panel to the core switch to supply it with the main optical signal from the internet service provider company. Also, we can find that this is the actual shape of installing the fiber patch panel. So this is the fiber patch panel, and this is the fiber optic cable going out of it to enter the core switch down here. As you see, this is the core switch. Then we have the outgoing fiber optic cables that are going from the core switch to enter the different switches on the network, which are those blue cables here. Very good. Now the next element we have in the network is the patch cord, which we have just talked about. And this patch cord is a copper cable that we have just talked about, as it connects between the patch panel and its related switch. And this patch cord copper cable is having a length of 1 or 3 meters. So according to the actual distance between the patch panel and the data switch inside the rack, we can get the patch cord length of 1 meter or 3 meters. Also, we can find that this is the actual shape of the patch cords. You can see it takes a U shape to connect between the patch panel and its corresponding data switch. Also, the number depends on the number of ports of the switch and its corresponding patch panel. For example, if we have a 24-port switch, we need 24 patch cords, and if we have, for example, 48 ports data switch, we will need 48 patch cords, and so on. Alright. Now the fifth component we have in the LAN network is the cable organizer, and this cable organizer works as a slot or a rack like this one that the patch cords are installed inside it. As for the more number of cables and to make our system more stable, we use this cable organizer for the cables routing process to organize and handle them well during the installation process, and also to help us during the troubleshooting process in case of the maintenance of the cables, as this cable organizer makes the troubleshooting process more easier. Alright. Now the last LAN component we need to discuss in this tutorial is the power distribution unit. And the power distribution unit is an element that is used to distribute the electrical power to the different switches and the different components inside our data rack, as the switches need electrical power as a supply to work, so we use the power distribution unit for this purpose. And it's essentially a group of power outlets that are designed to be installed inside the rack. For example, if we are having 3 data switches inside the rack, we will need a power distribution unit with 3 outlets at least, as each outlet will feed its corresponding data switch with the required electrical power. Also, we can find that this is the shape of the power distribution unit, and also this is the second model of it, which has many outlets according to the required number of elements inside the rack that we need to feed with the electrical power. And the important note about those outlets is that we should calculate the total required power according to the number of devices that we need to feed. And this is to be able to size the power distribution unit by calculating its rated current and its rated power, and by calculating the size of its power cable or its cross-sectional area. More than great. So that's about this tutorial, at which we continue talking about the different LAN components. Hope that's clear right now. Thank you for watching and see you next tutorials.